Ma'am?
Yes.
Ma'am, the charge on a salt depends upon what, ma'am?
That is the next topic. Okay, so we will start with the charge on the Sol, and here there are different reasons how the charge is there in the colloidal solution, and the most common reason is preferential adsorption of ions from the solution. Preferential adsorption. Okay, some examples I will say, you will understand. So different conditions. It is the most common reason is preferential adsorption of ions from the medium. Or what a medium is, the dispersion medium is the solution, isn't it? And so other reasons are also there. I told you, this year the passage question, that means the first 5, they give a passage and ask 5 questions. The first 5 questions were from this. So the very first question was this only: what is the reason for charge of the colloidal particle, which you asked now. And so any reason you can say. The most common reason is preferential adsorption of ions from the solution. Another reason is during electrodispersion, electron capture may take place. So those colloids will be negatively charged due to electron capture. And the third reason is electrical double layer, that I will be explaining now. Okay, so the most common reason is preferential adsorption of, no video. Video is not there.
Now it is common.
Okay. So the most common reason is preferential adsorption of ions. Okay, so here the questions, there are some examples are given. They can directly ask you the examples. So I think I should go to the board for explaining that. Okay, the first case. If you add silver nitrate, can you see, to potassium iodide solution. Board is clear? So, can you see the board?
Yes, ma'am.
No.
So this is the first example. If you add silver nitrate to potassium iodide, what do you get? You get a precipitate of silver iodide, isn't it? And suppose the silver iodide precipitate, and if potassium iodide is in excess, that part in the book it is not mentioned. Actually, it is like that only. If silver nitrate is added to potassium iodide, where potassium iodide is slight excess, then the precipitate, this is the precipitate of silver iodide, it will absorb I- ions, and the salt will be negatively charged. And if
And when potassium iodide is in excess?
Slight excess.
Okay.
So then I-, this is the precipitate, it will absorb common ion. So
Ma'am, it is an excess for to get extra I- ions.
Yes. Two. These are all examples. In this case, you will get a negatively charged colloid. Suppose you are adding silver nitrate to potassium iodide, in which silver nitrate is in slight excess, then the precipitate will absorb silver ion. So you will get here a negative salt and here get a positive salt. Clear?
And the positive part once more, ma'am.
It's okay? Is it okay?
Ma'am, that positive part once more, ma'am.
Positive part is the other way around. Suppose I am adding silver nitrate and potassium iodide, in which silver nitrate is in slight excess.
Okay.
So the precipitate will absorb silver ion.
Okay.
And you will get a positively charged salt. This is the first example. Here, these are all questions will be, what happens when silver nitrate is added to potassium iodide in excess. So you will get a negatively charged colloid. Or if potassium iodide is added to silver nitrate in excess, you will get positively charged salt. Understood?
Yes.
Okay, next example. Examples you have to study. They will ask what happens, like that only. Next example, ferric chloride. When it is added to hot water, you will get a positive salt. So when ferric chloride is added to hot water, you will get a hydrated ferric oxide, and that will absorb Fe plus ion, and you will get a positive salt. If ferric chloride is added to NaOH, you will get a negative salt, which is Fe2O3XH2O OH minus. So this is the second example. Got it? You have to learn like that. This happens, positive salt. The question will be like
Ma'am,
that.
can you explain once more?
Okay?
Ma'am,
Hmm.
could you explain once more the second Fe2O3, that one?
Fe2O3. Wait. Kirtana aska. Okay. This is the second example. If the same ferric chloride, if you add to NaOH solution, then you will get a negative salt in which the precipitate, this is the precipitate, Fe2O3XH2O, absorbs negative ions. You will get a negative salt. Clear?
And for Fe2O3, it is a positive salt.
Same, FeCl3 plus hot water, you will get a positive salt. Here, this is the precipitate.
Oh,
Here,
okay, yeah.
it is the same. Absorbing ions only different.
Mm-hmm.
That is what Anand asked. How this is happening? How the charge comes? Preferential absorption.
Ma'am, then the examples given in that box, right?
Yeah, box. Which examples that are positively charged salts and negatively charged salts? That example.
Yes, ma'am. Negatively charged metals, copper, silver, gold, and such, right? How does it
No, they
take?
are negatively charged. The main reason, one reason is, I told you already, na? They can take electron during, see, these metals normally we make by electrodispersion, isn't it? While making electrodispersion, electron capture can take place. So there are different reasons in different cases, different reasons. Okay?
Okay, ma'am.
Who is this? Who asked me now?
Anand.
Anand. Okay. So that is it. Anand understood?
Yes, ma'am.
Ma'am, so the ion which is forming that positive or negative, it depends on the compound which is in excess, right?
No, not in all the cases. So that is why the examples you learn. In the first case, it is preferential adsorption. It changes due to it changes in different cases. In the first case, it is that only. In the first case, you have to learn like this. If silver nitrate is added to potassium iodide in slight excess, you will get a negatively charged salt in which I minus is adsorbed. In the second case, if potassium iodide is added to silver nitrate in slight excess, then the precipitate is the same in both the cases. Silver iodide will absorb the silver ions. That is case 1. You have to, example 1, you have to learn like that. Okay? In the second case, you cannot apply that. In the second case, you will learn. These are all learning little by heart. So in the second case, you will learn like this. When ferric chloride is added to hot water, you will get a positive salt. The salt in which Fe3 plus is adsorbed. When ferric chloride is added to NaOH solution, you get a negative salt in which the precipitate is the same. Fe2O3 XH2O. That will adsorb OH minus. Clear?
Yes, ma'am.
So questions they will ask like that only. In this chapter, the number of questions, each one they take. And so that is it. Hey, can you tell me what is the significance of Tyndall effect? Yesterday I forgot to tell you. Once they asked what is the importance of or significance of Tyndall effect.
Ma'am, it helps to determine the size of the particles in the colloid.
No. Size how it is determining? No, it is not determining the size.
Depending upon the wavelength, ma'am, of the
No.
light.
Tyndall effect. I am asking about the Tyndall effect.
Ma'am, it helps us understand Brownian movement.
No, Tyndall effect is different from Brownian movement.
Ma'am,
Arbas is coming now.
it helps us identify whether a solution is true or wrong.
Very good. Priyanka? Is it Priyanka or Kirtana?
Priyanka, ma'am.
One is that. One is it is you will be able to identify a true solution and a colloidal solution.
Ma'am,
By
that you have given yesterday, right, ma'am?
yeah, my question is that only. The
Okay.
second one is I explained everything. The question I did not say. The second point is see the ultra microscope was devised. The scientist who discovered ultra microscope using this Tyndall effect, isn't it? I told you one sentence is there, isn't it? He devised ultra microscope by this Tyndall effect. Okay?
Yes, ma'am. That is good.
Okay. So the now coming back to our charge. So here the charge, the first question you can underline. The charge on the colloidal particle is due to one or more reasons. First reason, electron capture by Sol particles during electrodispersion of metals. The second one, preferential adsorption of ions from solution. Underline that. And the preferential adsorption of ion is the most accepted reason. Okay, now after that you have to learn the examples given A and B, ferric chloride and silver nitrate, potassium iodide. Got it? Now coming to the next topic, electrical double layer or Helmholtz double layer. So you know that the colloidal particles are charged. In a colloid, the particles are having either positive or negative charge. Suppose the colloid is positively charged. The positive charges will attract negative ions from the medium. That is just attraction. Okay, so what happens? There is already a layer of positive charge, and around that there will be a layer of negative charge, isn't it? Why? The positive charge is attracting counter ions from the solution. So
Ma'am, can you repeat, ma'am?
you know that the colloids are charged. Suppose the colloid is a positively charged colloid, there will be a layer of positive charge. I will go to the board. Suppose the colloid is positively charged. So there will be a layer of positive charge, and this will attract counter ions from the solution. So there is a layer of positive charge which is surrounded by a layer of negative charge. So this is a double layer, isn't it? So this double layer is called Helmholtz double layer. Clear?
Yes, ma'am.
So this is the electrical double layer or Helmholtz double layer. And so you may be thinking, then how do you say it is neutral? No, it is not like that. The first layer is the fixed layer. The second one is only a diffused layer. So the charge will be due to the first layer. Okay. And since there are two layers, positive and negative, there will be a potential difference between the two layers. That potential difference is called zeta potential. Got it?
Ma'am,
So
what do
Yes,
you
ma'am.
mean by diffused layer?
diffused is not a fixed layer. It is diffused means not a little loose. It's not a proper layer.
Okay, ma'am.
The first one is the correct. The charge is due to the first one.
Okay, ma'am. Got it.
Okay. Now I'll take the book. They may ask you what is Helmholtz double layer. So the combination of two layers of opposite, you have to learn as such the definition. The combination of two layers of opposite charges around the colloidal particle is called Helmholtz electrical double layer. The combination of two layers of opposite charges around the colloidal particle is called Helmholtz double layer. Okay. So then the next one is the potential difference between the fixed layer and the diffused layer of opposite charges is called electrokinetic potential or zeta potential. Understood? So the very next paragraph was asked this year. I said, now how do you explain the stability of colloids? So you have to, if they ask the stability of colloids, the next small paragraph, the presence of equal and similar charges on colloidal particle is responsible in providing stability to colloidal solution because the repulsive forces between the charged particles having same charge prevent them from aggregating when they come close to one another. This I explained yesterday.
Ma'am, where is this, ma'am?
Huh?
Where is this line, ma'am?
Are you Helmholtz double layer paragraph have you seen?
Yes, ma'am. Below
Next.
that, if two particles are insoluble of an insoluble material precipitate, that is given.
Electrokinetics, zeta potential have you seen?
Yes, ma'am.
Next paragraph. Presence of equal and similar charges on the colloidal particle. Have you seen now?
One second, ma'am.
Where are you
It's
looking
not
at?
given in this, ma'am. It's not given in this. It's like if two particles of an insoluble material precipitate do not have double layers, they can come close enough to attract van der Waals forces.
Now,
To
which
pull them.
book is this? Textbook?
Yes, ma'am. This is a textbook, ma'am.
Which one? The new one?
One second, ma'am.
Yes, ma'am.
Ma'am, even I have the same thing written in my book.
Okay, read it. I don't have that sentence.
Ma'am,
Read it.
This is a
even
2018 edition, ma'am.
Hmm? Okay, read the sentence, then I will say which is better.
One second, ma'am. I'll read out.
Hmm.
If two particles of an insoluble material that is precipitate do not have double layers, they can come close enough and attractive van der Waals forces pull them together. When particles possess double layers as shown in figure 5.13, the overall effect is that the particles repel each other at large distances of separation. This repulsion prevents them to their close approach. They remain dispersed and the colloid is stabilized. It's given like
Okay, this sentence, my sentence is better. You write down then.
okay, ma'am.
You write. Okay.
One second, ma'am. Yes, ma'am.
Ma'am, what will be the question?
Question is, how do you explain the stability of colloids? How do you account for the stability of colloids?
Yes, ma'am.
What happened to Shashank? 1 minute. Problem in the video call. Okay. Okay. So the sentence you write, the presence of equal and similar charges, the presence of equal and similar charges on colloidal particle is responsible for the stability. Equal and similar charges on colloidal particle is responsible for stability because the repulsive forces between charged particles
Because the
because the repulsive forces between charged particles having the same charge prevent them from aggregating. Okay,
okay, ma'am.
so that is about the charge.
Ma'am, your voice was breaking. Prevent them from after that.
Aggregating. Why Abhishek is going and joining? You are not listening, Abhishek? Abhishek, in between, where are you going? Abhishek, are you there? Now next is electrophoresis. I have to explain. I will explain the experiment first and then explain explanation. Okay? You have to take a U-shaped tube and take a colloidal solution. Suppose the colloid is a positive colloid. Okay, I can take any colloid, positive or negative. Dip two platinum electrodes, positive and negative, and we are going to apply an electric potential. Okay, so before applying the electric potential, suppose this is the layer, initial level, before applying the electric potential, and the colloid is positive. And if when I apply an electric potential, the positively charged colloidal particles will move towards the negative electrode and the level will come like this. Here it will be reduced. This will be the new level here and here. Isn't it? That means the colloidal particles, when an electric potential is applied, the colloidal particles will move towards oppositely charged electrode. That is called electrophoresis.
In this case, the colloid is positive.
I just gave an example. Positive, so what happens? The particles are positively charged. It will move towards the negative electrode, so the new level is this. Earlier it was here, till here. Since the colloidal particles are moving, the level will increase here, and similarly the level from here will decrease. Okay. So this experiment demonstrates.
And in the opposite case, if the colloid is negative, then the opposite will happen.
It will move towards it. So here the level will increase.
Okay, ma'am. Got it.
So this demonstrates electrophoresis. Okay? Any doubt?
Clear, ma'am.
Okay. So that was electrophoresis, the next property. That means this property, there are questions, different questions. One is, what is electrophoresis? Explain the following, they can give electrophoresis. And the second question, the very first sentence given, the existence of charge on the colloidal particle is confirmed by electrophoresis experiment? So that will be the question. How do you confirm or how do you prove the existence of charge on the colloidal particle? Okay, so two ways it can be asked. So here the charge, since the colloidal particles are charged, that is why the level of water increased in the limb carrying the negative electrode, isn't it? Are you listening?
Yes, ma'am.
Yes,
Yes.
ma'am.
Okay, so that is electrophoresis understood. You have to, this is the experiment I have to demonstrate electrophoresis, or the experiment to demonstrate that the colloidal particles are charged particle. You take the colloid in a U-shaped tube and dip two platinum electrodes in it, and when you apply an electric potential, the colloidal particles will move towards oppositely charged electrode. Okay, so this
Ma'am, anything that we should underline in the book? Proper
that
explanation.
okay. Definition, the first sentence you underline. The existence of charge on the colloidal particle is confirmed by this experiment. When electric potential is applied across two platinum electrodes dipping in a colloidal solution, the colloidal particles will move towards one or the other electrode. You understood that sentence? Because if it is negatively charged colloid, it will move towards positive electrode. If it is positively charged colloid, it will move towards negative electrode. The movement of colloidal particles under an applied electric potential is called electrophoresis. Okay? That is it.
Yes.
Now, next one is electroosmosis. Electroosmosis, suppose I do not allow the colloidal particles to move. Okay, so I can prevent the movement of the colloidal particles. Then when you apply same arrangement, I took a colloidal solution, the movement of the dispersed phase or the colloidal particles I stopped, I can prevent. And then if I apply an electric potential, instead of dispersed phase, in the previous case, the dispersed phase, the colloidal particles moved. Na? When if you prevent the movement of the colloidal particles and when you apply an electric potential, the dispersion medium will move. That is called electroosmosis. Understood?
Yes, ma'am.
So
Yes, ma'am.
electrophoresis and electroosmosis. So the sentence electroosmosis, when movement of particle is prevented by suitable means, it is observed that when in electrophoresis, the movement of particle is prevented by some suitable means, it is observed that the dispersion medium begin to move, and this is called electroosmosis. Any doubt in that?
No, ma'am.
So the next topic, coagulation. This is also the, see, you know that this is also very important. So many questions from this topic, coagulation. That is,
Ma'am,
uh,
ma'am,
hmm,
only one doubt is there.
hmm.
What is begins to move in an electric field, ma'am? What do they mean by that?
The
I think.
dispersion medium will move,
Okay.
not the dispersed phase.
All right. All right.
Okay.
All right.
Now, the next topic is coagulation. Coagulation, you know that colloid means the particles are dispersed, isn't it? The reason for the stability of the colloid is the charge, right? And suppose you remove the charge by any means, then the colloid becomes unstable and settle down under gravity, or it will get precipitated. That process is called coagulation. So coagulation is settling down of colloidal particles. When it is settled down, it is no more a colloid, isn't it? So settling down of colloidal particle is called coagulation. Understood? So the process of definition is given in bold letters. The process of settling of colloidal particle is called coagulation or precipitation of the salt. Understood? And this year they asked, write 2 methods of coagulation of colloids. Any 2 methods. Like that, this year question was there. So there are different methods. One is electrophoresis. When electrophoresis, the particles are moving towards one electrode. So that is one method. And the second method is we have to remove the charge. If you add an ion having an opposite charge, then a coagulation will take place, isn't it? Another method is by boiling. This year some children wrote heating, it is mark was not given. Boiling is the method. Another method is by adding an electrolyte. If you add an electrolyte, then coagulation will take place. So in the book they have given the different methods by electrophoresis, by mixing 2 oppositely charged salts. So if oppositely charged salts mixed in equal proportion neutralize their charge and get completely precipitated. Next one is boiling. When you boil, the adsorbed layer is disturbed and so precipitation will take place. Another method is persistent dialysis. So when I taught you dialysis, I told you, if you remove the full complete 100% electrolyte, then the colloid will become unstable. Little bit of electrolyte is required for stability. I told you, isn't it? So persistent means continuous dialysis. That is the next method. And the last method is addition of electrolytes. So 5 methods are there. Last method is addition of electrolytes. Understood this much?
Yes, ma'am.
Yes, ma'am. But if we are asked the question, should we explain it or can we write like by
No,
electro for?
methods only. See,
Okay.
in a board exam, everything will be 1 mark question. So you don't have to, unless in that if the explanation is asked. So here, if they ask what happens when the colloid is boiled, like that way also they can ask. If that is the question, then you can say that if when the colloid is boiled, then the dispersed medium layer will be disturbed due to collision. Okay.
Ma'am, can you repeat the addition of electrolytes point?
That I am starting only. Addition of electrolytes. That is the most important point. Okay.
I thought I missed that.
So if you add an electrolyte, then coagulation will take place. Okay. So addition of electrolytes. See, there is a rule called Hardy-Schultz rule. Okay. So when you add an electrolyte, suppose the colloid is positively charged. Okay. And so when you add an electrolyte will contain positive and negatively charged ions. Which ion will cause coagulation? The colloid is positively charged. And when you add an electrolyte, which ion of the electrolyte will cause coagulation?
The negatively charged.
Negatively charged. So that is the flocculating ion. Flocculating ion or the coagulating ion. Okay. Got it? Got that much? See,
Yes, ma'am.
Yes, ma'am.
when you add an electrolyte, the colloid is, suppose the colloid is negatively charged, then the positive ion of the electrolyte will cause coagulation. So that ion which cause coagulation is the coagulating ion or flocculating ion. And there is a rule which says that greater the valency of the flocculating ion, greater will be the coagulation. Understood? Hardy-Schultz rule. Greater the valency of the coagulating ion, greater will be the coagulation. So based on that, questions will come. Okay. So I will go to the board. So, if I take Fe3 plus ion, will have more coagulating power than Mg2 plus ion, which is more coagulating power than Na plus. You agree? Hardy-Schultz rule, isn't it?
Yes, ma'am.
This is in the case if the flocculating ion is a cation. Suppose the flocculating ion is an anion. PO4 3 minus will have SO4 2 minus Cl minus. So this is the rule. Greater the valency of the flocculating ion, greater will be the coagulating power. Understood?
Yes, ma'am.
And now the questions. The question they will give. They will ask you to arrange in the order of increasing coagulating power, or they will ask which one is having more coagulating power. The anion is the same. The cation will change, isn't it? So which is having the most coagulating power? FeCl3. Understood?
Yes, ma'am.
Yes, ma'am.
And
Ma'am, one thing I
another
want.
way they may ask you lithium chloride, sodium, this way. Here the anions, all the cations are having the same valency. So which one is having more coagulating power? This one. Isn't it?
Yes, ma'am.
Ma'am, how is that so?
Because here the cations are having the same valency. Anions are only different. So this is a PO4. Its valency is 3. Here valency 2. That is 1. So this is
Okay.
the most. This way the question comes from that point.
Ma'am, what is flocculating?
Flocculating ion is the coagulating ion. I said what is flocculating ion? The ion which causes coagulation. Understood?
Yes, ma'am.
So from the electrolyte, the topic is we are adding an electrolyte and that causes coagulation. So from the electrolyte, if the colloid is positively charged, negative part is causing coagulation, isn't it? If the colloid is negatively charged, the positive part of the electrolyte is causing. So which part is causing, which ion is causing coagulation? That is the coagulating ion or flocculating ion. Clear?
Yes,
Yes,
ma'am.
ma'am.
So questions also indirectly they will ask you. Okay. Then one more thing is there, coagulating value. Coagulating value. So the minimum concentration of the electrolyte in millimole per liter required to cause precipitation of the sol in 2 hours is called the coagulating value. Underline that. That is called the coagulating value. The minimum concentration of the electrolyte in millimoles per liter required to cause coagulation of a sol in 2 hours is the coagulating value. So coagulation, so many questions. Hardy-Schultz rule. Any other doubt? Any doubt on this? Any doubt, children?
No, ma'am.
We'll go ahead. The next one, next topic is Coagulation of lyophilic salts. And here in this topic, lyophilic salts are more stable. The reason is they are highly solvated. What do you mean by solvated? The solvent will be, it is surrounded by a large amount of solvent. They are highly solvated. So coagulation of lyophilic salts means you have to remove the charge and you have to remove the solvent, isn't it? There will be always a solvent layer around the colloidal particle. That is why they are more stable. So the charge you can remove by adding an electrolyte, but the solvent you have to remove, isn't it? So the solvent we can remove by adding another solvent. Suppose the dispersion medium is water and we want to coagulate the lyophilic salt. So we have to remove that water layer. For that, we will add an organic solvent like alcohol. So alcohol is a dehydrating, it will dehydrate the water layer. Then you add an electrolyte, then coagulation will take place. Understood?
Yes.
So that is about the coagulation of lyophilic salt. And next topic is protection of colloids. So the lyophobic colloids, there only protection takes place. To protect the lyophobic colloids, see, some of the lyophilic colloids have the property of this protection, protecting the lyophobic colloids. They are called the lyophilic colloids, which protect the lyophobic. That means to protect the lyophobic colloids, we can add lyophilic colloids. The such colloids are called the protective colloids. Okay. So what are protective colloids? The lyophilic colloids, which are used to protect the lyophobic colloids. How they protect? They form a layer around the lyophobic colloids. Have you understood?
Yes, ma'am.
So anybody, any doubt? Any doubt? We'll move ahead. Okay. Okay, so that is about the lyophilic colloids. And now the next topic is emulsion. Emulsion is also very, very important. Shashank has joined. Shashank? Left, I think. Okay. So emulsion. Emulsion, what do you know? It is, emulsions are liquid in liquid. Dispersed phase and dispersion medium both are liquids, isn't it? So there are two types of emulsions. Oil in water and water in oil. What is oil in water? Oil is the dispersed phase and water is the dispersion medium. And the second type is water in oil. Water is the dispersed phase and oil is the dispersion medium. So there are two types of emulsions. From emulsions also, the questions, different types of question. One question is give examples of each type. Okay, so oil in water, milk and vanishing cream, and water in oil, butter and cream. That you have to learn by heart. So book you take, I'll tell. So one more question can be asked. So two types, oil in water and water in oil. And so examples. Here the second paragraph. The examples of oil in water, milk and vanishing cream. Underline that. And examples of water in oil, butter and cream? That is the first question. Okay. The second point is that the emulsions are unstable. So if you just mix, they will not stay for long. They are unstable. So a stabilizing agent is required. You have to add a stabilizing agent which is called emulsifying agent. That is the next question. For both the types, different substances are added for stabilizing the emulsion. So the examples you have to learn by heart. So here the examples. Next paragraph. Emulsifying agent for OW emulsions are proteins. The first case, the emulsifying agents are proteins, gums, natural and synthetic soaps. You have to learn by heart. Proteins, gums, natural and synthetic soaps. And the second type, it is heavy metal salts of fatty acids, long chain alcohol and lamp black. This much understood? So two questions, examples, and second question, the emulsifying agent of both types.
Ma'am, what is lamp black?
Lamp black is the lanterns you have seen in olden days. The electricity was not there. People used to make the lamp. No? So the lanterns, the lamp, or you can just there, it will be after burning, there will be black residue. No? That is lamp black. That is carbon only. Lamp black is carbon only. Okay. So this much clear? That is the second question, the emulsifying agent. And the third question, four questions are there from emulsion. The third question is write some properties of emulsions. That is the paragraph, write some properties of emulsion. If you want to dilute an emulsion, you can dilute with any amount of dispersion medium. If you add dispersion medium, you can dilute. Suppose you add the dispersed phase, then the emulsion becomes unstable. That is the property 1. You can dilute the emulsion by adding any amount of dispersion medium. Okay. Now, the second one, the droplets of emulsions are negatively charged and can be precipitated by electrolyte. Okay. The droplets of emulsions are negatively charged and can be precipitated by electrolytes. Third point, they show Brownian and Tyndall effect. So 3 points. Understood the properties? You can dilute the emulsion using any amount of dispersion medium. Second point, the emulsions are negatively charged and can be precipitated by any amount of electrolytes. Third point, they show Brownian movement and Tyndall effect. They are colloids, so they will show Brownian movement and Tyndall effect. Now the fourth question is the last sentence. Emulsions are liquid in liquid. If you want to separate the liquids, that can be done by heating, freezing or centrifuging. If you want to separate the two liquids, you can do that by heating, freezing and centrifuging. Clear? So even though it
Yes, ma'am.
is 4 questions, I told you 4 types of questions. Even the last sentence was asked. Okay. Now,
Ma'am, what was the question for the last sentence?
last sentence, how do you separate the two liquids in an emulsion?
Okay, ma'am.
Ma'am, for the 3 points, what is the question, ma'am?
Question, the properties of emulsion. Okay?
Okay. Yes, ma'am.
Okay. Now, next one is colloids around us. And here, one more questions can be asked. Blue color of the sky is due to scattering of light by dust particles, isn't it? There are so many colloids in the atmosphere. The blue.
Even the small droplets of rain.
Yes. So there are so many colloids. So the blue color is due to the scattering of light. Underline that.
Ma'am,
Ah,
if we mix water and oil, ma'am, In that case, what can be an emulsifying agent?
See, water in oil. So the it depends on the dispersion medium. Dispersion medium, if it is water, then the emulsifying agent will be that the first one, the heavy metal salt of acids and the long chain alcohol, lamp black. So first one is proteins, gums, isn't it? Proteins, gums, natural and synthetic soap. If the dispersion medium is opposite, then the second one. It depends on the dispersion medium.
Okay, ma'am.
So blue color, you have to underline that sentence. Dust particles along with water suspended in air scatter blue light. So scattering of light by dust particles along with water suspended in air. Underline that. And from this one page and the second page also so many questions are there. Applications are very, very important. Okay, so that is blue color. Now fog, mist, rain. Here one question is one more question. Fog, I told you, na, fog is liquid in gas, isn't it? That is one question. And then the next question is the last sentence. How do you cause artificial rain? These are the two questions. So the first one point is fog is liquid in gas. That is the point. And you can go back to the table given in page 134. Fog, mist, cloud, they are aerosol, liquid in gas. Okay. And the last part, it is possible, underline and learn. This was asked once. It is possible to cause artificial rain by throwing electrified sand or spraying a soul carrying a charge opposite to one on the cloud from an aeroplane. That they asked. How do you cause artificial rain? Okay.
How do we determine the charge on the cloud?
There may be methods. Okay. So then throwing electrified sand, nothing is required. Then for spraying a soul, the charge may be required. Okay. Now food articles, milk, butter, halwa, ice cream, fruit juices are colloids. Blood. Here also one question. The colloidal solution, blood is a colloidal solution of albuminoid substances. Underline. Colloidal solution of albuminoid substances. The styptic action of alum and ferric chloride is due to coagulation of blood forming a clot. That was asked. What is styptic action? Styptic action means if bleeding takes place, the blood should clot, isn't it? So that is the styptic action of alum and ferric chloride is due to coagulation of blood. Okay, underline that. Then soil. So soil also colloidal in nature, in which humus acts as protective colloid. These are all one mark they can pass.
Ma'am.
Ah.
What is the albuminoid substance, ma'am?
Albumin is a protein. No?
Yes, ma'am.
So it is an albuminoid substance. It is a colloidal. That is why it is a colloid.
Okay, ma'am.
Then formation of delta. Many times they asked how to explain the formation of delta. So there the river water. So delta is formed where the river water meets the sea water, isn't it? So river water is a colloid. Colloidal solution of clay. River water is a colloid and it is a colloidal solution of clay. When sea water comes and meets river water, sea water contains electrolytes. So coagulation will take place and a delta is formed. That is very important. So here I will read out. River water is a colloidal solution of clay. Sea water contains a number of electrolytes. When river water meets sea water, the electrolytes present in sea water coagulate the colloidal solution, resulting in the deposition with the formation of delta. Understood? Formation of delta. That was a board question. So you have to say that this in simple sentence also you can say. The first thing, colloid is river water. River water is a colloidal solution of clay. And sea water contains a number of electrolytes. When sea water meets the river water, coagulation takes place and delta is formed. Okay, understood?
Yes, ma'am.
So,
Yes,
so
ma'am.
many questions. Now it is you may find it very easy, but questions, so many questions. That is why, Saurav, I say you have to attend the classes. So then you read, then you will get. Okay, Saurav?
Okay, ma'am.
So don't be lazy or don't sleep too long. The class timing, you have to get up and come. Okay? Now, next question, application of colloids. Next one, application. Here also so many questions. Each application there is a question. So it is not very easy application of colloids. The first one is electrical precipitation of smoke. This I will explain and then I will tell you what to write. Yeah, so the smoke coming out from the industries, they pollute the atmosphere, isn't it? So what they do, the smoke, before letting out to the air, that the smoke is allowed to pass through a chamber or a room which contains the which contains plates having a charge opposite to that of smoke. Got that point? So we are not, so what happens? In that room, we are passing the smoke and the room the plates are fitted with a charge opposite to that of the smoke. So then coagulation will take place and the smoke particles will settle down. So this is to reduce pollution. Understood? This is called the electrical precipitation of smoke. And the name of that is Cottrell precipitator. Cottrell. Cottrell precipitator. Understood?
Yes, ma'am.
Yes,
So
ma'am.
this is also electrical. So what you will write? Smoke is a colloidal solution of solid particles such as carbon, arsenic compounds, dust, etc. Now the precipitator is the smoke before it comes out from the chimney is led through a chamber containing plates having a charge opposite to that carried by smoke particles. The particles on coming in contact with these plates lose their charge and get precipitated. This much you have to say. Cottrell precipitator or electrical precipitation of smoke. Any doubt?
Ma'am, what about the diagram?
Diagram you can Cottrell and all 1 mark question only.
Okay, ma'am.
Okay. So purification of drinking water. Alum is added. Alum to purify the drinking water. See, the impure water is a colloid because impurities are dispersed. So when you add alum, coagulation will take place. Underline that and learn purification of water. Okay. Alum is added to impure water to coagulate the suspended impurities. That is enough. Okay. Now, the next one is very important. Application of colloids in the field of medicine. That is the question. Right? The application of colloids in the field of medicine. So, there they have given different medicines. Each medicine can be asked as a 1 mark. Argyrol, first one. Argyrol is an eye lotion. The first colloidal medicine is argyrol. Argyrol means it is a silver salt. And colloidal antimony, second one, is used for curing kala azar. Colloidal antimony And colloidal gold is used for giving intramuscular injection. Milk of magnesia for stomach disorder. 4 colloids you have to learn. Argyrol, eye lotion. Colloidal antimony, curing, Kala-Azar. And colloidal gold is used for intramuscular injection. And milk of magnesia for stomach disorder. Here another board question, the last sentence. Colloidal, underline that, very important. Colloidal medicines are more effective due to large surface area and can be easily assimilated. So 2 points you have to write. Why are colloidal medicines more effective? 1 point, due to large surface area. Second point, they can be easily assimilated. Clear? You see that each point questions are coming.
What is assimilated?
They can be absorbed easily.
Okay.
Okay. So are you marking the questions?
Yes, ma'am.
So that is medicine, in the field of medicine. Next one, tanning. So tanning is what? Animal hide. Hide means skin. The animal hides are positively. Tanning is hardening of animal skin. Okay. So they are saying animal skin is positively charged. So for you will add tannin, which is negatively charged, and coagulation will take place. That is how hardening of animal skin, tanning will take place. Okay. And here that is the question. And you have to say animal hides are colloidal in nature, having positive charge. When it is soaked in tannin, which contains negatively charged colloidal particles, mutual coagulation take place. This results in hardening of leather. So that is how tanning takes place. That is the first question. Second question is chromium salts also can be used. That is asked as a 1 mark question. Tannin is used for hardening of leather or tanning. Another one is chromium salt. That also can be asked. Now, cleansing action.
Ma'am, tanning is just the other name for hardening of leather, right?
That is tanning, Tanning.
Yeah, so that is just another name for hardening of leather.
And the other one, the colloid we add is tannin, Tannin. The bio students must be knowing they are extracted from plants, isn't it?
Yes, ma'am. Yes, ma'am.
That is tannin. Now, photographic cleansing action we already learned. Photographic plates. Anybody asking any question? Photographic plates. Here also question is there. And here see photographic. What is the application of colloids in photographic plate? Okay, so the photographic plate is prepared by coating an emulsion of light sensitive silver bromide in gelatin. So they are prepared by silver bromide in gelatin. Underline that and learn. Then rubber industry. Rubber industry, you know that rubber is you get a rubber from the milk of, you know how to, you must be having an idea now, the milk of rubber is taken from the stem, isn't it? And that is when it comes out and then it hardens, it is the milk is the latex. And the latex is a colloidal solution of rubber particles which are negatively charged. And coagulation, rubber is obtained by coagulation of latex. Okay. And many industrial products like paints, inks, synthetic plastics, rubber, all are colloidal solutions. So this chapter is done. Anything, any doubt you want to ask? So many questions, so many topics. Colloids around us, I told you many questions, isn't it? And application of colloids, you just go through once and ask the colloids around us. Any doubt if you have, you ask, or any topic, any doubt?
Ma'am, can you explain coagulation of lyophilic salts once?
Okay, 1 minute. Okay, Naomi.
Yes, ma'am.
Which one? Prashant is asking which one? Once more. Which one, Prashant? Okay, Naomi's question first. Coagulation of lyophilic salts, isn't it? So you know that lyophilic salts, the stability of lyophilic, they are very stable. Lyophilic salt stability is due to two reasons. One is charge. Second one is solvation. So the lyophilic salts will be highly solvated. And so to to coagulate the lyophilic colloids, we have to remove the solvent layer first. And then for removing the charge, you will add an electrolyte. So to remove the solvent layer, suppose you will add another solvent which will remove the solvent layer. For example, suppose the solvent is water. Then you will add an organic solvent to remove it. So once the solvent layer is removed, then you add an electrolyte, you can cause coagulation. Clear?
Ma'am, for coagulation, to cause coagulation, first you must add a solvent and then an electrolyte.
No.
Or is it an option, like if you can add electrolyte or solvent?
No, you have to, the main reason for the stability is the solvation. So solvent layer you have to remove first. Then add an electrolyte.
Okay, ma'am.
Now Prashant asked Cottrell precipitator, isn't it? So Cottrell precipitator is used to precipitate the smoke, or you can say coagulation of smoke. So from industries, the smoke, if you let the smoke out in the air, it causes pollution. So what they do, they let the smoke go into a chamber, and the chamber contains plates having a charge opposite to that of smoke. So coagulation, the smoke, the dust particles will settle down in the chamber. Clear, Prashant? Is it okay? Any other doubts?
Ma'am, in the application of colloids, yeah. So it's in this cleansing action of soaps and detergents. It's given in section 5.4.3. So that the whole thing you should explain if that is asked, or
no, that you know. No, already you learned in this in 10th standard, na. That they may not ask that. If they ask, you know the action, na, cleansing action.
Yes, ma'am.
So if there is no doubt, then we will take, see tomorrow, not today, it is too much, but then tomorrow learn and come. The children who are not learning properly, you have to learn and come tomorrow. Questions I will again ask. Learn that so many questions are there. Don't take it very lightly. Okay. So what I will do, wait.